In this section, we are talking about the third way to solve systems of equations, and that is to eliminate. So we're talking about elimination using addition and subtraction. So on example one, we're just going to kind of learn by doing here. On example one, we're using elimination with addition. So rather than subbing in one of the equations into the other one, we look for somewhere in this system of equations, or systems of equations here, where I can actually add these together and one of the variables will cross out. So let's see how that works in this first example. If I were to add these equations together, so I'm going to add my like terms together from top to bottom. I would add negative 4x plus 4x, which is 0. That term cancels. 3y minus 5y gives me negative 2y. And negative 3 plus 5, this should be a nothing. There should not be anything there. That is a typo. Negative 3 plus 5 gives me 2. All right, so now what I actually have is I have negative 2y equals 2. I only have one variable now, and I can go ahead and solve for that. So I'm going to divide by 2, negative 2, excuse me, to get y by itself. Now I have y equals 2 divided by negative 2 gives me negative 1. Right, so I solved for y, now I'm going to solve for x. So your next step is just plug in negative 1 and for y in one of the equations. This is a lot like what we did with substitution. So I'll just pick the second equation just for fun. It doesn't matter which one you do. So in that second equation, I'm replacing y with negative 1 equals 5. So I do my PEMDAS here. So I have 4x. And then negative 5 times negative 1 gives me plus 5 equals 5. I'm going to subtract 5 from both sides to get x by itself, and I get 4x equals 0. If I divide both sides by 4, I am then left with x equals 0. Now I have what x equals, I have what y equals. My answer then is 0, comma, negative 1. There is my answer. All right, now same thing over here on 1b. I'm going to try to add these two equations together. But you'll notice here that now the y's and the x's are not directly lined up with one another. So I'm going to move this equation around a little bit so that I have my like terms lined up with one another. So what I'm going to do in this first equation, I'm actually going to switch around 4y and 3x. I'm going to switch places. So if I do that, I have 3x plus 4y equals 22. And if you're wondering why the heck can you do that, well, think back to our properties. The commutative property says I can add things in whatever order I want. And then that second equation, I'm going to copy down. So now if I add these two equations together, I have 3x plus 3x, which gives me 6x. 4y minus 4y, those end up canceling out. This is what I want to happen. It's exactly like what happened over here on example 1. When I added negative 4x plus 4x, we got 0. Those canceled out as well. So same thing happens on 1b here. 4y minus 4y cancels out. And then that equals 22 plus 14 gives me 36. So now to get x by itself, all I got to do is divide by 6. 36 divided by 6 gives me 6. So there's my x. Now I'm going to plug x into one of the equations. I'll do the first one this time, just switching it up. It doesn't matter which one you plug it into. So I have 4y plus 3 times 6 equals 22. So I'm plugging in 6 for x. I'm going to go ahead and multiply that together. So 3 times 6 gives me 18, and this equals 22. Subtract 18 from both sides, and I get 4y equals 22 minus 18 gives me 4. If I divide both sides by 4, now I'm left with y equals 1. So my answers are y equals 1 and x equals 6. So my answer as a coordinate pair is 6, comma 1. And there's my answer. So now on to example 2. There's a just one more step we got to do. We're given a verbal equation now. We're given a verbal system of equations, and we're going to set it up algebraically and then solve. All right, so as a whole, it says the sum of two numbers is -10. -3 times the first number minus the second number equals 2. Find the numbers. So it seems like a lot of mumbo jumbo. Look at just the first sentence at first. So I'm going to draw a line to break that up here really quick. Looking at just the first sentence, I have the sum of two numbers is -10. So two different numbers means I gotta define two different variables. So I have x plus y. That's the sum of two numbers right there. Remember, sum means to add. It's a bad plus sign there. A sum of two numbers is means it's equal to. So this is equal to -10. My stylus is not cooperating. There we go. All right, so there's my first equation. The sum of two numbers is -10. Now on to the second equation. -3 times the first number minus the second number equals 2. All right, so first of all, -3 times the first number. I'm going to break it up right there. -3, I know what that is. -3 times the first number. The first number I wrote was x. So I'm going to put x there. -3 times the first number minus the second number. Remember, minus means I'm going to subtract. So minus the second number, which was y, equals 2. This tells me it equals 2 right there. This equals 2. So the thing you got to kind of get used to here with systems of equations is that you got to have a little bit of foresight. If I add these together, I'm trying to look for a variable that will cancel out. That happens here with plus y and minus y because they're opposites of one another. So if I go ahead and add this together, I have x minus 3x gives me -2x. Y minus y, those cancel. And then this equals -10 plus 2 gives me -8. So now I can solve for x. I'm going to divide both sides by -2 to get x by itself. I'm left with x equals -8 divided by -2. Remember, a negative divided by a negative is a positive. So this equals 4. Then I got to plug this back into x in one of the equations. The easiest one will be that first equation. So I'm going to plug this into x plus y equals -10. So I'm going to replace x with 4. 4 plus y equals -10. I subtract 4 from each side. I'm left with y equals -10 minus 4 gives me -14. So here's one of my answers. Y is -14 and x is 4. So the first number is 4, the second number is -14. So on to the next page, we have a word problem and then we'll be done. So this word problem says, Tamara and Christine are throwing a birthday party for their friend. Tamara invited 5 fewer guests than Christine. Together they invited 47 guests. How many guests did each girl invite? All right, so let's break this up. The first sentence, Tamara and Christine are throwing a birthday party for their friend. And I know that I'm trying to figure out how many guests each girl invited. So I'm going to go ahead and define some variables. I'm going to say T is the number of guests Tamara invited. And I'm going to say C is the number of guests Christine invited. So now I've defined my variables. That should be your first step. This second sentence, Tamara invited 5 fewer guests than Christine. So she invited 5 less guests than Christine. So I know the number of guests Tamara invited equals 5 less than Christine. So I have C minus 5. So I can think about that as I know that if Christine invited 10 people, this is just an example. If Christine invited 10 people and Tamara invited 5 fewer, she invited 5. So 10 minus 5 gives you 5. Then the next sentence, together they invited 47 guests. So all in all, they invite 47 guests to their birthday party. So I know the number of guests Tamara invites plus the number of girls or of guests that Christine invites has to equal 47. That's that total there. All right, so now I got to add these together to eliminate a variable, but you'll see these aren't all lined up with each other because the equal signs are in different places. So what I'm going to do with that first equation, the first equation is t equals c minus 5. I'm going to go ahead and subtract c over to the other side. So now I have t minus c equals negative 5. If I line that up then, here's my system, right, that I came up with. I'm going to line that up with the next equation, which was t plus c equals 47. So here's my new system. You'll notice that I have a negative c and a plus c. That's exactly what I want to happen because I know when I add together these equations, my c's will cancel out and I can solve for one variable. So if I scroll down a little bit so we have room, I'm going to add these together. When I do that, t plus t gives me 2t. Negative c plus c, those cancel. And that equals negative 5 plus 47, kind of like saying 47 minus 5 is 42. And then divide both sides by 2 to get t by itself. And I get that t equals 21. Now I just got to plug that in to one of my equations. I'm going to plug it into the second one. It doesn't really matter, but I'm just going to do that. So I have t plus c equals 47. I'm taking 21 and putting it in for t. So I have 21 plus c equals 47. I'm going to subtract 21 from both sides. And I have c equals 47 minus 21 gives me 26. And I can double check my answer a little bit here because it says in the problem, Tamara invited 5 fewer guests than Christine. Tamara invited 21, Christine invited 26. That is 5 fewer indeed, so that is my answer. So you would say Tamara invited 21 guests and Christine invited 26 guests. There we go.